Hi, my students. Saxon Algebra 2, Lesson 81, we're going to talk about dividing complex numbers. Dividing complex numbers. What is a complex number again? Oh, right, it's this. It's A plus BI format where A and B are real numbers and I is an imaginary number. Imaginary numbers come about when we have things like, well, let's just make it simple. Square root of 5. This would be reimagined as 5 times minus 1, and then we would say square root of 5, and this square root of minus 1 becomes an I. So, square root of minus 1 equals I. That is one piece of the complex number canon. And the other one is that if we have two i's and we multiply them together, that equals minus 1. And we're going to use this tool in our calculation several times. So, this is a quickie little review on complex numbers, how they come about, how we treat them, and how we present them. Always separately. We never would use a fraction underneath the whole expression. We would have separate fractions. We'll see that in this problem as well. So what happens if we want to divide two complex numbers? 2 plus 3i over 4 minus 2i. Okay? Now, we're not going to be able to divide this in the old school sense of creating a division box and putting in the top number and, estimating, multiplying, subtracting, and bringing down, the old school type of division. What we're going to do, though, is hear a screaming alarm whenever we see an imaginary number in our denominator. Just like radical signs, we don't like them there. We want our denominator to always be a nice rational number. So when we see a problem like this, we're not truly going to divide it, but we are going to simplify it, or the way my brain thinks of it, we're going to clean it up because we don't want that I down here. Just like we don't want square roots in the bottom. The tool that we'll use to fix this screaming siren is the very same tool, the conjugate. Conjugates with complex numbers work exactly the same as conjugates with radicals. You simply change the middle sign, leave everything else the same, and then we do it top and bottom. Remember, we're multiplying those two together. Okay, so this is our conjugate, and it's actually the denominator that helps us set the conjugate. The top is to the right. Okay, so we're going to multiply now. We'll do the bottom first, just like we've done in the past, simply to make sure that the conjugate really works the way it should. So we have 4 minus 2i times 4 plus 2i. Here comes the dance. 4 times 4 is 16. 4 times that is minus 8i. Here comes the magic. There's the plus 8i. And then I'll do this the slow way. You can speed it up once you get the hang of it. The final pair of factors will multiply to give me minus 4i squared. Okay, but we set up here that I squared equals minus 1. So this turns into a minus 1. When I multiply those together, I get plus 4. And I want to put that over here with my 16 because I'll be able to add those. So I'm going to just gently draw that line through there to remind myself that I've taken care of all this. That's now over here. This cancels, and so my denominator simplifies to 20. Ah, what a nice, clean and neat, rational number to have for our new denominator. All right, the top is still going to have drama, but that's okay. We don't mind that. We're going to multiply these two pieces. 2 plus 3i times 4 plus 2i. We're not going to get that neat canceling, but that's okay. We don't need it. 4 times 2 is 8. 4 times 3i is 12i, everything's positive. This way we get another 4i, and then here, again, we'll go in step, positive 6i squared. But the I squared is equal to minus 1, so this becomes minus 6. Make sense? Okay, minus 6, I'm going to draw a line through that because it's all represented over here. I add 2 plus 16i. That's my new top, or numerator rather. Okay, so now I'm going to start writing this, and we have a little bit of simplifying to do. We've got 2 plus 16i, and I know that this is the denominator, but remember we want this separate, crisp presentation, so I'm not going to write it all together. I'm going to put this over 20, and I'm going to put this over 20. That can be reduced. 2 over 20 reduces to 1 over 10, and 16 over 20 reduces to what? We can take 4 out of both of those, so it will be 4 out of 5, and that's our final answer. Cute, right? I like it so much. All right, and there's just one more of these. Example 81.2. Our problem this time, I'm going to write it down as it is, but you'll see that you can take a little shortcut. 4 minus 2i is our denominator. Now, when I look at that's the numerator, excuse me. I'm so busy thinking about this denominator. 2i minus 3. No. This is not the right format for a complex number. So I'm immediately going to correct that. 4 minus 2i over minus 3 plus 2i. Never ever do I let this presentation stand. The I should always be at the back, the plain number should be at the front, and I wouldn't even copy it out of the book this way if I was doing the homework. I would just immediately fix it to the right presentation before I write it down. But now it's fixed, and our conjugate will be minus 3 minus 2i. Remember, this front sign never changes. If it's positive, it stays positive. If it's negative, it stays negative. It's only the middle sign that changes. Minus 3 minus 2i, top and bottom. We're multiplying. Here comes the bottom. Denominator, to be precise. And I have to write top or I don't feel like I've done my job. Okay, the bottom. Minus 3 plus 2i times minus 3 minus 2i. Positive 9 minus 6i. Oh, here comes the magic. Plus 6i, the two negatives go together, and then this becomes minus 4i squared. I like to just write this everywhere. I squared equals minus 1. I told you we would use that in this problem, and we have. So this becomes a minus 1. These two together become positive 4, right? Because this already was a negative. Okay, simple line to cross that off. This cancels, and our new denominator is 13. Okay? For some reason, I like to put a squiggly line under that. It's my halfway point. I don't know. Now we do the top. 4 minus 2i. That's a little bit messy, but there the minus sign is clear. 4 minus 2i times minus 3 minus 2i. Here we go. Minus 12 plus 6i minus 8i, and then here comes the crazy part, plus 4i squared. The I squared turns into a minus 1, so this becomes a minus 4. This adds to minus 16, and this adds to, let's see, minus 2i. Sound good? Okay, so that's our new numerator, and we're going to write this as 16 minus 2i over 13 13. Notice how I wrote that separately instead of one big line and a 13 together. That's to keep our A plus BI presentation neat, crisp, and clean. Final answer. And that's the end of lesson 81.